welcome back to my channel. Today we will discuss on chapter 4 forces. So in this video we are going to discuss subtopic 4.2 part 3, okay, where we will discuss questions number 12. Okay, so here we have 3 identical cubes, okay, where all identical meaning that same size, same weight, same mass. Okay, so here 3 identical cubes x, y, z. So this is actually x, x, y, z are at rest in a straight line on a smooth horizontal floor. And the question also mentions that it's on a smooth horizontal floor. So when it's a smooth horizontal floor, meaning that there's no frictional force, okay, in contact of each other as shown. So a horizontal force, 12 Newton force act on the cube X. So this 12 Newton here actually is our F external force. Is a pushing force. Is pushing on the block X. And the external force here is equal to 12 Newton. So the first question A, the accelerations of the cubes. So when you want to find accelerations of the cubes, the easiest way is we can find using the total resultant force. So we can use Fx total equals to ma. Okay, because we are using F total, meaning that our mass also we use total mass A. So in these questions, okay, what we can see here, F external here is pushing X. So the X that we have, the X total is only have 12 Newton. And the mass for x, y, z is 2 plus 2 plus 2 times a. Meaning that the accelerations for this system is equal to 2 meter per second squared. So for questions B, find the resultant force acting on each cube. Okay, so if it refers to x, our x for our x cube, Fx equals to ma. Okay, so because the resultant force acting on x, so we take mass for x only, where mass for the x is 2, and the acceleration for the whole system is also 2, so we will get 4 Newton. Okay, so similar for y equals to ma, of course m also my acceleration, and again we will get 4 Newton as well. Similar for our z cube, where our m also 2 kg and acceleration also equals to 2. So we will get all force acting on each cube is 4 Newton. For question C, the force acting on y due to the pushing by x. Okay, so there is a force acting between the x and also y cube. Okay, meaning that there is a reaction force that y acting on the x, okay, and there is a reaction force that x acting on y. Okay, so if we label this is r y on x, okay, so this one will be r x on y. They have the same magnitude, but different direction. So I will label this as negative because the direction is to the left. Okay, so they will have the same magnitude but opposite direction. So this is what we call action and reaction. Okay, so now we want to find the force acting on y due to the pushing by the x. Okay, so if we are referring to cube x, okay, so we need to draw free body diagram, where for x we have weight for x, we have normal force for x, okay, we have the F external, okay, where it is equals to 12 Newton, and also there is a reaction force that y acting on x, okay, and the motion is to the right, meaning that our F external minus r yx, because it's opposite direction, equals to ma. Okay, so F external is just now is 12 Newton, r the reaction force y acting on x we don't know, and it is equals to 2 times 2, so it's equals to 4. So therefore, the force acting on Y due to the pushing by X, or we label as the reaction force YX, equals to 12 minus 4. So therefore, we will get 8 Newton. Okay, we will get 8 Newton. Questions number 13. This is a questions for inclined plane. A block accelerate with 3.1 meter per second, okay, down a plane inclined at the angle of 30 degree. So the angle here is 30 degree, and the motion is moving downward with the accelerations of 3.1 meter per second square. And the accelerations due to gravity 9.81. What is the coefficients of the friction? So meaning that here there is a friction and we want to find mu. Okay, what is the value for the coefficients of friction between the block and also inclined plane? So before we want to do this type of questions, we need to draw free body diagram. So the first step is we need to ask 5 questions. So we need to always ask whether we have the weight, friction, tension, normal, and also F external. So the first one, weight. Okay, weight will always acting downward. Okay, we're always acting downward. And we also have frictions. The friction is always oppose the motion. Since your motion is acting downward, so our friction will oppose the motion. Frictional force will move acting upward. Okay, we don't have tension, but we do have normal force, where our normal force is always perpendicular 90 degree with the contact surface. Okay, so this is contact surface, so it's 90 degree. And we also don't have the external force. Okay, so after that, you need to resolve it into X and also Y component. Okay, so bear in mind that because this is an inclined plane, so meaning that this direction is X component, this one will be Y component. Okay, and for our weight here, we can resolve it into X and also Y component. Okay, so for weight here, we can resolve it into, this is our Y component, and this is our Y component, and also we can resolve it into X component. Okay, where the angle here is equal to 30 degree as well. Okay, so if we want to resolve it, we can resolve it. Okay, so I will draw out the free body diagram for this block, where here we have a normal force. Okay, we have the frictional force, and also we have the weight. Okay, and this weight also we can resolve it into, okay, we can resolve it into our weight for X component. Okay, where is equals to weight mg sine theta. Okay, because the angle is 30 degree at here. And also we can resolve it into weight for Y component, where it is equals to mg cos theta. Okay, next we will try to create equations for X and also Y component. So we start with X component, Fx equals to ma, and this time a is not 0 because they give you 3.1, it's accelerate. So if you refer back to this one, the motion is moving downward. Okay, so our Wx or mg sine theta is positive because it is same direction with the motion. Okay, plus negative frictional force because the frictional force directions and the motion is opposite, and is equals to ma. Okay, ma. A is 3.1. M we don't know. So this is the first equations that we get. This is our first equation. Okay, second equation is from y exit. Fy equals to ma, And for Y component, because the block is not moving up or down, so we know that Y component, the resultant force is balanced. Okay, it's balanced and is equals to 0. Okay, meaning that our normal force, okay, upward plus negative mg cos theta, because it's downward, is equals to 0. Or we can write it as normal force is equals to mg cos theta, because it's balanced. Force acting upward equals to the force acting downward. Okay, so this is our second equations. So remember, our frictional force, we still have another equations where the equation for frictional force is equals to mu n. Okay, is equals to mu n. So we can substitute n inside equations 1. Okay, we can substitute our equation 2 into equations 1, where equation 1, okay, from equation 1 we know that okay, equation 1 we know that our mg sine 30 minus mu n is equals to 3.1 m. So you substitute into the equations where n we substitute mg cos, so we will get equation become mg sine 30 minus mu mg cos 30 equals to 3.1 m, where here we have m, and m we can cancel. So at the end, we will get g sine 30 minus mu g cos 30 equals to 3.1. Then what should we do? Okay, we can factorize out. Okay, we can factorize out where our mu g cos 30 equals to 3.1. This one shift to the other side, so it's equals to 3.1. Sorry, not 3.1. We can write again, g sine 30 plus 3.1. So since we want to get only mu, so we take mu as a subject. G is equals to 9.81 sine 30 plus 3.1 over g cos theta, so it's 9.81 cos 30. Okay, so if you press calculator, you should get 0.212. So for the coefficients of friction, there is no unit, so you don't need to write unit. Okay, no unit for the coefficients of frictions. Next, we are going to discuss on questions number 14, where for questions number 14, there's two objects, M1 and also M2, where M1, the mass is 2.5 times 10 to the power of 3 kg, and also we have M2 is connected with the cable, so this is M2, and the mass is 4 times 10 to the power of 3 kg. This second mass M2 is suspended over a pulley. Okay, so this is a pulley. The inclined angle is 30 degrees and the surface is frictionless. So meaning that there is no frictional force. So determine the accelerations of the system and the tension in the cable. So if you refer here, M1 only 2,500 kg, M2 is 4,000 kg. Okay, so meaning that M1 will push upward the motion and M2 will moving downward. Okay, the motion, because M2 is 4,000 kg. So now we need to resolve it into X and also Y component. Okay, after we draw the free body diagram. So the first step, what should we do is we need to draw free body diagram. For M1, there is a M, the weight, okay, acting downward. Let's say I label it as M1. We label it as weight 1. And we have tension because there is a string. And also we have the normal force. we don't have friction, and also we don't have external force. Okay, so these are the three forces acting on M1. Okay, and if we draw, okay, this is our, okay, actually we can resolve it weight, we can resolve it into weight for x component, weight for y component, where the angle here is equals to 30 degree. Okay, so why you will get 30 degree? Okay, so I will draw out, okay, why we will get 30 degree. Okay, because this is a triangle. This is a triangle. Okay, and we know that if this is 30 degree, here 90 degree, okay, so this part will be 60 degree. Okay, 60 degree. So if here 60 degree, meaning that because this is a perpendicular, is a right angle 90 degree, so here will be 30 degree. Okay, okay, so we need to resolve, okay, we need to draw the free body diagram for M1. Okay, so meaning that, okay, this is tension, normal force. Okay, our weight 1 is acting downward, but we can resolve it into weight 1 y component and also weight 1 for x component. Okay, and the angle is 30 degree. Okay, so for M, okay, for M1 we can resolve it into x and also y component, where x component equals to MA. Okay, x component, which one is x component? Okay, this is your x component. Okay, this is the x component, and this is your y component. Okay, and the motion is acting upward. The motion, okay, is the motion. So the force that similar direction with the motion is positive. Okay, so here x component we have tension, and also we have weight for x component. So we will take tension minus weight because tension direction is similar with the motion. Okay, so the motion, this one is upward, and M2 will going downward. Okay, so because the tension is similar directions, okay, but the weight here is a mg sine theta is opposite direction. Okay, so we will take tension minus mg sine 30, the angle, and is equals to MA. So the first equation we will get is tension equals to MA. M here is 2,500. A plus 2,500 G sine 30. So this is our first equation. Okay, the second equation of course is from y component. Fy equals to MA. Okay, so since there's no motion, or the resultant force for y component is 0 because it's static, okay, it's balanced, so it's equals to 0, meaning that our normal force for this case will equal to weight for y component, where we can write as mg cos 30. This is our second equation. Okay, the third equations we will get, of course, is from M2, where M2 we only have weight 2 and also tension only. There's no frictional force because there's no contact, and also we don't have normal force. Okay, and also we don't have the external force because there's no pushing or pulling force. Okay, so for M2 is much more easier because we only have tension and also we have weight 2. Okay, and the motion is downward. So for M2 we only have one equation where Fy equals to MA. And for this case, A is not equals to 0 because it is the accelerate downward. Okay, this motion is accelerate downward. The motion is accelerate downward. Therefore, we will take weight 2. Okay, minus tension equals to M2A. Okay, so tension will equals to M2 is 4,000. A this one weight 2 weight 2 is 4,000 G 9.81 minus 4,000 A. Okay, so this will be our third equations. Okay, so since here we have tension, here also we have tension, both tension are similar because they are from the same string, okay, same cable. So therefore, we can write, okay, we can find, use equation 1 equals to equation 3. Okay, we substitute all the value inside, where we have 2,500A plus 2,500G sine 30 will equals to equation 3, 4,000G minus 4,000A. Okay, so G, you substitute 9.81. Finally, our acceleration, you will get answer is 4.15 meter per second square. Okay, so you substitute the value G, you will get the accelerations, where the accelerations is equals to 4.15 meter per second square. Okay, so this is the first part where you can get the acceleration. Okay, next we goes to tension. So after you obtain the acceleration, you substitute back to equation 1 or equation 3 also can. Okay, so I will substitute into equation 1 where tension equals to 2,500A. I substitute 4.15 plus 2,500G, 9.81 sine 30 degree. So the tension that you get the value, you will get 2.264 times 10 to the power of 4. Unit is Newton, because it's a tension. Okay, it's a one type of force. Okay, so this is questions number 14, where it is involved for the inclined plane. Okay, next one we will go to questions number 15. The next questions. A man of 60 kg is standing inside the lift. So this is a case, lift case. Okay, this is a case where the man is standing inside a lift. Okay, so this is a lift. This is a man and is standing inside. Okay, on a weighting scale. Okay, calculate the reading of the weighting scale where the lift is moving upward. Okay, so this one is very important, where the lift, the motion is acting upward with the acceleration of 2 meter per second square. So what should we do is we need to find what is the reading. Okay, so actually the reading here for the weighting scale, we are referring to the normal force. Okay, so for this person, it experience a weight, and also it will experience a normal force. Normal force is the reading and the weighting scale. Okay, so for this case, we only involve y component, where Fy equals to ma. Okay, and a is not 0. A is not 0. Okay, so from here, normal acting upward, weight is acting downward, and the motion accelerate upward. So we must take normal minus weight or weight minus normal. Okay, you must refer back to the motion. So since the motion is acting moving upward, so meaning that we must take normal minus mg, or the weight, equals to ma. Therefore, normal will equals to ma plus mg. Then you substitute the value inside, where the mass is 60, acceleration is 2 plus 60, 9.81, and finally you will get 708.6 Newton. Okay, so this is the reading of the weighting scale, where it's actually referring to the normal force. Okay, next one, the last questions number 16, where a student 40 kg stand inside a lift. Again, this is a lift. Determine the apparent weight of the student if a lift is moved. So the apparent weight, actually we also refers to the normal force. Okay, we are referring to the normal force. So for the first case A, if the lift is moved downward with constant speed. Okay, so constant speed, actually they give you the information, V constant, A is equals to 0. Okay, so F net for this case, F net equals to MA. Okay, so this student is inside and the lift is moving downward with constant speed, meaning that your acceleration is equal to 0. So again, we have normal force. This is what we call apparent weight, and we have weight. So for this case, because the motion is downward, so we will take weight minus normal equals to MA. Okay, weight is 49.81 minus normal equals to 48. Okay, where A is equals to 0. So meaning that the apparent weight is equals to 40 G, or is equals to 392.4 Newton. Okay, because the question say constant speed, so constant speed A is equals to 0. So this is 16A. Next we go to 16B. 16B is the lift downward with constant acceleration. Okay, so 16B is again F equals to MA. So for this case, the lift is downward, but the acceleration is not 0. Acceleration is equal to 0.5 meter per second square. Okay, so here we have weight and also we have normal. Okay, so we must refer back to the motion. The motion is downward, meaning that the weight minus normal equals to MA. Okay, so normal will equals to weight minus MA. Okay, weight here is mg, so it's 40g minus 40 A is 0.5. Okay, so finally you will get 372.4 Newton. Okay, because there is an acceleration. 16C. The lift is moved upward with constant acceleration. So 6C is the student, still the same, 40 kg. There is a weight and also normal force. But now the lift is acting upward, moving upward. Okay, so our F net equals to MA. Okay, so for this time, because the motion is upward, so we will take normal minus weight, because normal direction is similar with the motion. Okay, equals to MA. Then your normal or the apparent weight will equals to MA plus mg. Okay, so m we can factorize out. It's 40. A is 0.5 plus g 9.81. So finally you will get 412.4 Newton. Okay, so that's all for this chapter. Thank you very much, and we will start a new topic number 5, work energy and power, in next video. Okay, so if you like my video, you can share with your friends and give me a like. Okay, see you on next video. Bye and have a nice day. Thank you.